Okay, so I've been asked to do a quick walkthrough for this question. There are two possible products from the hydrolysis of silicon tetrachloride. Compound A is Si2OCl6 and compound B is Si3O2Cl8. A 0.1 gram sample of one of these compounds is reacted with an excess of water and all the chlorine present was converted into chloride ions. This was then titrated against silver nitrate and 42.10 centimeters cubed of 0.05 moles per decimeter cubed was required to react with all the chloride ions. Identify the sample contained in compound A or B. So we need to work out whether what we've got in the solution is either A or B, working on the number of moles that we've reacted with against the silver nitrate. So the way I approached this question was to first work out the number of moles of chloride ions of compound A and compound B that will be present in a 0.1 gram sample. So I'll do that first. So I've got compound A. And the number of moles of compound A will be worked out by number of moles equals mass over mR. I've got a mass of 0.100 grams, and the mR of compound A is 286.89, and that gives me a number of moles of 0.0003486. Now there are 6 chlorines in compound A, so I'll take that number there and I'll multiply that by 6. Which will give me 0.0021. And then I'll do it for compound B. So compound B, again, number of moles equals mass over mR. I've got the same mass, potentially, and I've got an MR of 339.89 this time. And gives me a number of moles of 0.00029421. I've got 8 chlorines this time, so this I will move that up a little bit, and this time I'll do 8 times 0.00029421, which will equal 0.0023. Okay, actually, if I round that up properly, it'd be 24. So next thing I need to do is work out how many moles of silver nitrate I had. So I'll just do moles of AgNO3, and that will be number of moles equals volume times concentration, and I've got a volume of 42.1. Remember to divide that by 1,000 because it's in centimeters cubed, wants to be in decimeters cubed, and I've got a concentration of 0.05, and that will give me a number of moles of 0.0021. So we can see that the number of moles here equals the number of moles of compound A that we thought we'd have, so we can confirm that this is compound A. Hope that was helpful. Thanks for watching and have a great day.